Concrete. It's the bedrock of our cities, the foundation of our infrastructure. But concrete has a weakness. It cracks. These cracks, often microscopic at first, can grow over time. They compromise strength and durability. This creates huge costs for repair and replacement. But what if concrete could heal itself? This isn't science fiction. Self-healing concrete is a game changer. Imagine concrete that can repair its own damage, like a living organism. This remarkable material is a reality, thanks to innovative research and development. Self-healing concrete promises a future of more durable, sustainable, and resilient infrastructure. It has the potential to revolutionize the construction industry. The days of unsightly cracks and costly repairs could soon be over. The implications of this technology are far-reaching, impacting everything from bridges and buildings to roads and dams. With self-healing concrete, we're entering a new era of construction, one where structures can withstand the test of time and the elements. Get ready to explore the fascinating world of self-healing concrete, a testament to human ingenuity and our quest for a stronger, more sustainable future. Self-healing concrete sounds magical, but the science behind it is surprisingly straightforward. There are a few different approaches, each with its own unique mechanism. Let's break them down. One method uses microcapsules, tiny capsules filled with a healing agent. Think of them as miniature repair kits embedded within the concrete. When a crack forms, it ruptures these capsules. The healing agent is released and fills the crack, effectively sealing it shut. Another approach utilizes bacteria, microscopic organisms that can induce the formation of calcium carbonate. These bacteria are incorporated into the concrete mix. When a crack appears and water seeps in, the bacteria are activated. They start producing calcium carbonate, which acts as a natural cement, patching up the crack from the inside out. A third method involves shape memory polymers, materials that can change shape in response to stimuli like temperature changes. These polymers are embedded in the concrete matrix. When a crack forms, the polymers can be activated to contract, pulling the edges of the crack back together. This self-healing process helps maintain the concrete's structural integrity. These are just a few of the innovative techniques being used to develop self-healing concrete. Researchers are constantly exploring new materials and methods to enhance its effectiveness and efficiency. The ultimate goal is to create a truly autonomous self-healing material that can repair itself without any external intervention. The development of self-healing concrete is a testament to the ingenuity and dedication of researchers worldwide. Among these pioneers, one name stands out: Henk Jonkers, a professor at Delft University of Technology in the Netherlands. Jonkers has been at the forefront of self-healing concrete research for over 2 decades. Jonkers' work has been instrumental in bringing this revolutionary material closer to reality. His research has focused on using bacteria to create self-healing concrete, a sustainable and highly effective approach. He's also explored the use of other bio-based materials, such as limestone-producing bacteria, to enhance the healing process. His contributions have earned him international recognition and numerous awards, solidifying his legacy as a true pioneer in the field. But Jonkers is not alone in his pursuit of self-healing concrete. Researchers across the globe are building on his work. They are exploring new materials, refining existing techniques, and conducting large-scale trials to bring this technology to the market. The journey from laboratory experiments to real-world applications is a challenging one, but the dedication and passion of these researchers are paving the way for a future where self-healing concrete is the norm, not the exception. Their work is an inspiring example of how scientific innovation can lead to groundbreaking solutions with the potential to transform our world. Section 4. Building the future. Applications and advancements. Self-healing concrete is no longer a futuristic concept. It's already being used in various applications around the world. One of the most promising areas is in infrastructure, particularly in structures subjected to harsh environments and heavy loads. Imagine bridges that can repair their own cracks, extending their lifespan and reducing maintenance costs, or tunnels that can withstand the pressure of mountains without requiring constant repairs. Self-healing concrete is making these visions a reality. Its applications extend beyond infrastructure. Self-healing concrete is being used in buildings, pavements, and even water-retaining structures. In each case, the material's ability to repair itself translates into increased durability, reduced maintenance, and a lower environmental footprint. But the future of self-healing concrete is even more exciting. Researchers are exploring ways to enhance its healing properties, making it even more efficient and versatile. Imagine concrete that can heal itself multiple times, or concrete that can respond to different types of damage. New materials such as bio-based polymers and nanomaterials are being investigated to further improve the material's performance. The goal is to create a truly autonomous, self-healing material that can adapt to its environment and repair itself without any external intervention, paving the way for a new era of sustainable and resilient construction. Section 5. A crack-free tomorrow. The promise of self-healing concrete. Self-healing concrete is more than just a technological marvel. It's a symbol of progress, representing a shift towards more sustainable and resilient construction practices. In a world facing the challenges of climate change and aging infrastructure, this innovative material offers a beacon of hope. Its ability to extend the lifespan of structures translates into reduced material consumption and waste generation, lessening the environmental impact of the construction industry. By minimizing the need for repairs, self-healing concrete also contributes to a more sustainable future. Imagine cities dotted with structures that can stand the test of time, requiring minimal maintenance and remaining resilient in the face of natural disasters. Self-healing concrete has the potential to make this vision a reality, reshaping our urban landscapes and improving the quality of life for millions. The future of construction is here, and it's self-healing. As we continue to innovate and push the boundaries of material science, self-healing concrete will play a pivotal role in building a more sustainable, resilient, and awe-inspiring world for generations to come.